This is the screencast for section 7.1, example 2. We're going to look at displacement here in example 2, and then we're going to look at total distance in example 3, but I'll talk about it real quick. Now, displacement is, I think you know it in science classes, if you have a test tube of water, and you drop a rock in it, you measure the initial level of the water and then the ending level of the water to find out what the volume of the rock is. You use the displacement, the change between the beginning and the end. Well, that's what displacement is in calculus too. Displacement is the change in position from the beginning to the end, so between the beginning and the end. Well, displacement equals the rate of change times time, and very similar to distance equals rate times time. Well, rate of change is a velocity, so v of t, and then change in time is delta t. So we really are adding up, like in this graph here, adding up all of the little velocities to get the total displacement from A to B. So we're taking the integral. And displacement can have positive and negative pieces to it, because maybe the particle will move forward and then backward a little bit and then all the way forward, fine. But total distance, like we'll see in example 3, has to be all positive areas. It's kind of like a car. No matter if you're driving north, south, east, or west, your odometer is putting on a total positive distance your car has traveled. However, if you go like north for 5 miles and then south for 2, your displacement is only 3 miles. You're only 3 miles away from home. So example 2, finding position from displacement. So suppose the initial position of the particle in example 1, and here's the equation over here, is s of 0 equals 9. What is the particle's position at A, t equals 1 second, and B, t equals 5 seconds? Well, the particle's position is going to depend on where it starts, and it's saying it starts at 9 units. So now we need just to find what the displacement is to know whether it goes forward a few units, backwards a few units, from start to finish. So let's take the equation s of t equals the antiderivative from 0 to 1 of v of t dt. So the integral of velocity over the span 0 to 1 seconds. That's going to be your displacement. Now I need to add on the initial position plus the 9 units we already started at. So here's your change in position plus your initial value. That will equal your final position. So taking the antiderivative of the equation from example 1 in my calculator, I get negative 3 2/3 plus 9. Which that means the final position of the particle is going to be 5 1/3 units at 1 second. Basically what happened was this particle started out at 9 units, and then according to this change in position, it went backwards 3 2/3 units and landed at 5 1/3 units. So that's where it is at 1 second. Now part B asks, what about t equals 5 seconds? Alright, so I'll just reset that up for 0 to 5 seconds. Now it's going to go backwards for those 3 2/3 units, but it's also going to then go forwards a ways too, so I'm pretty sure this particle is going to be to the right of 9 units. So let's take the displacement and add on the initial position to get the total final position. Found that in my calculator, and I get the antiderivative from 0 to 5 of my equation is 35 plus 9, which means 44 units is where the particle will be at 5 seconds. So the now try problem number 1 is a continuation off of the now try problem from example 1. We have a particle that's traveling with the velocity 5 cosine of t, and we want to find the particle's displacement for the given time interval. If s of 0 equals 3, what is the particle's final position? Okay, so I'm going to set up the position equation by taking the displacement and adding the initial position. I can do that displacement in my head, or not in my head, but by hand without a calculator. Oh, maybe in my head, I guess. Integral of cosine of t is sine of t, and then I'm going to evaluate that from 0 to 2 pi. And then, of course, I'm adding my 3 on the end for the initial position. And so now that tells me two things. That tells me, first of all, the displacement is 0. Second of all, it tells me the final position is going to be 3 meters.